everyone. This video is about input, variables, data types, and some basic mathematical calculations. Okay, so the way that I'm going to run this video is a little bit different from some of the other videos where, like here's what a data type is. This is how we say this and blah, 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 blah. I'm going to actually do this through an example. So what I'm going to do is I'm going to write a program with you, and then I'm going to explain the pieces of the syntax and point out how that relates to the program. So I'm doing it backwards. I'm not presenting all of the syntax and then doing an example. I'm doing the example first and then presenting the syntax on that example after. Okay, and then talk a little bit about the quirks and so on. So before we begin, if you don't know what this program is doing, you should go and watch the Hello World video first, because it's important that you actually have a foundation on this. That video is pretty short. Go and watch it, come back, and then watch the rest, okay? Because you really need to know this stuff before you continue, okay? So let's get started. So what we have here is we have basically the skeleton, the outline of a program. Now, right now, there's no code. There's no real code. All I have is I have sort of like just an empty function that doesn't do very much except return 0. So what are we going to do with this? So what I have sort of in between where it says main and the number include is I have what is called a comment. So /* begins the comment, / ends the comment. And a comment in programming terms is a place where you can put human readable language so that you know what is about to happen, or it might be a description of something. Essentially, it's a note about the program that you write into your program. The compiler always ignores everything that's inside a comment, so you can write yourself little notes about what you're doing using comments, okay? Commenting is, we call that documentation, is a really important part of programming. And later on, you will have rubrics that say if you decide never to write any comments, we will decide to take off 30% or something like that. Okay, so please make sure that you actually follow the guidelines in terms of documentation. Now, you might think that, whoa, that's harsh. I don't write something and I'm going to get big deduction. Well, I have a friend who has fired people because they didn't do this. Okay, so this is not trivial. It's something that we're teaching you not just to be, hobby programmers. We're teaching you to be professional programmers. You have to follow professional standards. Part of that is writing comments. Now, in any case, I digress. Let's continue to talk about this. So this is a comment. We call this a multi-line comment. So the comment starts as /* and it ends as //. But sometimes we just want to very quickly write a comment at the end of the line and we don't want to end it. So the next line is the ending. So those kind of comments begin with 2 slashes. So if I do this // it starts a comment and the comment ends at the end of the line. You cannot put code after the // because this, starting from here, this will be a comment. Now, what I'm going to do before we start this program is I'm going to talk about what it is that I want to write in comments. And that way I can just simply follow like what it is that I want to do. So the program that I want to write is one where we ask the user to enter a height in metric, and then we're going to output that height in imperial units. Now, originally, I wanted this to be like, there's going to be feet and inches and blah, 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 blah. But that program got really big really fast. And I didn't want this video to be too big because there's actually some very important content here, even without all of that extra stuff. So I'm going to keep this really simple. We're going to write a program that will take in the height of somebody in centimeters, and we're going to output that height in inches only in this video. Later on, I'm going to add all the other bits to well, now what if I want it in feet and inches? How do I do that? But for now, it's just centimeter to inches conversion. So it's a fairly simple algorithm to do that. So what do we do? Okay, so what I want to do now is I want to say what it is that I want to do in English first. So what all the steps are in human language, then we'll turn it into C code. So when you're first programming, this is very common way to deal with like a really large problem. I need to do this, then I need to do this, then I need to do this. Write it all out. And that will make it easier for you to write the C code, because then you say, oh, I need to do this. How do I say that in C? Oh, I need to do that. How do I say that in C? That makes it a lot easier to do. As you get better at programming, you will be writing a step, and then the amount of code that needs to do that step might be like 20, 30 lines before you move on to the next step. And that's pretty normal, okay? So, but for now, I would suggest more of a very small step approach. So I want to write a program that's going to ask the user to enter height in centimeters. We call this asking prompting. Prompt user to enter height in centimeters. Okay, so this is what we call prompt. Okay, and then once we prompt them, so prompting just basically means, hey, do this, user. Okay, and after we do that, we want to read in the height. Okay, so we ask the user to enter something, they enter something, we want to read it in. Read in the height in cm. And then we want to calculate the height in inches based on height in cm. So we're not just like, it's based on whatever the user enters. We're going to make that, we're going to take that number, we're going to do the math on it, turn it into how many inches, and then we're going to print out the result. That's it. This is that's all we're going to do. Print out the result of this calculation. So how do we go about doing that? Okay, let's start. Now, so prompting the user to enter height, that's really just displaying some text on the screen. Please enter blah, 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 blah. That's all we have to do. And we already know how to do this because this is essentially hello world, but we don't say hello world. So we're going to use the printf function. And remember, whatever goes inside the double quote is what prints out to the screen. So we're going to just put in, please enter the height in centimeters. Okay, and that's it. And then double colon and then a space. Now, why is this colon here? Well, it's just, because sometimes, you want it to show up so that it looks like you can type something, right? So you have that as sort of like, this is the end of what I'm writing. Put a little space so that when the user starts typing, it isn't hugging the colon. That's just for prettiness. Okay, now in hello world, we put a /n. But if I put a /n here, then what will happen is that the user's cursor is going to be on the next line, and that's going to look kind of weird and ugly. So I'm not going to put a /n here because I want, when the user types something, I want it to be just after that colon. So I'm going to do that. Okay, so no /n. And then I want to read in the height in centimeters. So how do I do that? Well, scanf, double quote, okay, now I'm going to just type this in, and then I'm going to explain it later on. Now, I also need something called a variable, because so what's going on here is I want to read in some information from the user. But to do that, I'm going to need something called a variable, which is a place where we can put the information. Okay, so think of it that way. If the user enters something, I need to be able to talk about the thing that they entered. So I need to give it a name. So I'm going to call that thing height in centimeters. Okay, I think like that, height in cm. Okay, now what is height in cm? Well, this is what we call a variable. This is a variable. Okay, it's a place for us to put a piece of information. Now in this case, it's a variable. This variable is something that the user enters. The user enters a number, we put it in this variable. And I'll talk about that in a more pictorial form in a moment. Okay, we're going to walk through this code still. And in order for me to read the data into this variable, I have to put an ampersand in front of first, and then height in cm. Now, why this ampersand? I'll talk about that in a moment. Just realize that you have to put it in. Otherwise, your program will crash really, really fast. But don't worry, I will explain. It's not a magic symbol. It's actually a very important symbol. We'll talk about that in gruesome detail over the course of this entire semester. So we start with that. Now, the next thing we have to do is we have to take so by this point, this variable, height in centimeters, is going to hold whatever the user enters. Okay, so whatever the user is entering, it's going to be put into this variable. So if I want to make a calculation involving that, I'm going to just have to make, I would just have to use this variable in a mathematical formula. So what is the formula to use? Well, I'm going to give it to you because this is something you could, and if you didn't know this, you would have to look up how to do this. Like that's part of the job of the programmer is to sort of become jack of all trades. You kind of have to learn how, like, what's the measurement, right? So the measurement is 1 inch is equal to 2.54 centimeters. Okay. Now, there's a conversion the other way, but I only remember this one. So what it means, though, by the way, is that 1 centimeter is equal to 1/2.54 inches. Okay, like that's the math. Okay, so if you want to think of it one way or the other, it it doesn't matter which way you think about it. That's the math. Okay, so what do we do with this? Okay, so if we have something in centimeters and we want to turn it into inches, all we have to do is divide it by 2.54. That's the math. Okay, so if I do this division, I probably want to store that height into a variable as well. So if I took the number like 25 and I divided it by 2.54, the number that I have is going to have decimal places, right? Probably. So I'm going to need something that can store decimal places, but an integer doesn't. So int height in centimeters is never going to store how many inches we have, right? So what we want to do now is we want to talk about storing that data into a variable somewhere, right? So let's talk about so something that can hold decimal places. Now there are two types of variables that can hold decimal places. One of them is called a floating point value, a float, okay? And the other, the one that we're actually going to use, is going to be called double uh, total height in inches. Okay, now that's a very long variable, Nick, but that's okay. Um, Actually, I have to shorten this because I have to draw this later. So we'll talk about this as height in inches, just like that. Okay, height in inches, height in centimeters. Okay, so how do we make this calculation? To talk about height in inches, all we have to do is simply say, well, this variable height in inches, well, that's just equal to our height in centimeters, oops, divided by 2.54. If I do this math, I should be able to get the correct height in inches, right? And at this point, after I've done the math, the variable height in inches is going to have whatever this calculates out to. The computer will do the math for us. We don't have to do the math ourselves. And then this is still going to hold the height in centimeters. I want to now to display this result, I'm going to still use the printf function. Now, printf, other than printing out exactly what we say in the double quotes, we can also do something that is sort of like a fill in the blank statement. Okay, so what does that mean? Well, what we're going to do is we're going to say uh, the thing that we want to print out, we're going to format it using something called the format code. Okay, so %d over here in the scanf statement, that's actually a format code. It's the format code for numbers, numeric values, integers. And so what we have here is when I want to do the output, I want to say, well, the height in centimeters, %d, is the height in inches, which is a floating point value. So for a double, the format code is %LF. That's for floating point value. And I don't want this to go on. I want a new line so that it looks pretty. And then I'm just going to put it in. So here, this is like a fill in the blank. So think of this as doing, the output is going to be blank, blank, blank is blank, blank, blank. Okay, like that's, and we should probably, put in some measurements here so that's easier to see. So the output is going to look like this. CM is blank, blank, blank inches, where the CM, where the blanks are going to be filled in. Okay, so these blanks are created by these format codes, and they're filled in by whatever I put in after the double quote, and then I use a comma to separate the things that I want to put into those blanks. So the first blank, I want height in centimeters. And the second blank, I want height in inches. Oops. Bleh. There we go. Height in inches. Done. And that will actually print out what I want. Now, I know that I've skipped on some details here. I'm going to talk about those in a moment. But before we do that, let's make sure our program actually runs. Oops, that's not what I wanted. One moment. So let's see how this works. So clearly I was playing with this earlier. So let's see how it works. So right now I have a file that I've saved, height in height converter 1.c. And what I'm going to do here is I'm going to compile it. So this is equivalent to hitting certain buttons in Visual Studio. Sorry, I don't remember what the buttons are. There's a menu item you can build and compile. It's in Lab 0, whatever those instructions are, follow it. This is the equivalent of that. You don't have to do it this way. This is my way of doing it because I find that this way is fast. If you're using Visual Studio Code, you would be doing something very similar, but just inside the box. Visual Studio Code, not Visual Studio. I'm talking to Mac people here. And if you're in Xcode, you hit the play button. That's it. That would be the equivalent of what I'm about to do. So when I type GCC, so GCC means compile. GCC height converter dot 1.c. This will compile my program. And then when I want to run it, I simply type a.out. Now, if you are on a Unix system, you might need to say /a.out because unless your path is, if your path is set to look at the current directory, you don't need to do this. But if it isn't, then you need to do this. So if a.out, if it says they can't find it, put // and then a.out. I don't have to because my paths are correct. So what happens when I run the program? Please enter the height in centimeters, 165. And then it says, well, that's 64.96 inches. Okay, so that's it. That's the math. Now, you should always make sure that your program is correct. So I am going to do that using Google. Convert cm to inches. If I search on Google, of course, they have this handy dandy result. Okay, so centimeters to inches over here. I'm going to make this a little bit bigger for us. And what does this have? Well, if I put 100 and did I put 65? That's 64.9606. And we have a few more decimal places, so it looks right, right? We have the same number as Google did. We're good. Okay, great. Okay, so we know now that this program seems to be working. Okay, but what is this? All of this? Let's go over this in a little bit more details. Okay, so I'm going to just make this a little bit smaller so that I have my drawing surface over here. What is happening to our program right after we start? What is this int height thing? Right? We said it was a variable, but what does it actually do? So we talked a little bit about computer hardware, and we said that one of the things that we think about when we buy a computer is we think about buying it with a certain amount of memory, right? Or RAM, right? And whenever we want to hold something, whenever we want to write a program, we will often want to work with data, and that data has to be somewhere in memory. And memory can be very big, and we have to have a way to reference this particular area in memory where our value is being stored. So what we do is we're going to create variables to do this. A variable is essentially a label for an area in memory that we will interpret a certain way. So let's take a look at our first variable here. It's an integer, int for integer. That means it's a whole number that can be positive or negative, and it's the height in centimeters. Now, what does that actually mean when it comes to my memory? So when my program gets to this line, it'll say, oh, you want a variable. And that variable is an integer. So it's going to find an area in memory where I can hold an integer. So memory does fill up with different variables from different programs. And so this is what we're going to do. We're going to take an area of memory and we're going to say, okay, you know this area right here? This area right here is going to be for my height in centimeters variable. I'm reserving it for my variable. So this area, we're going to call this, I'm going to just put HCM because I don't really want to write it all out. So height in centimeters, that is our variable. So this variable here, okay, I will put in brackets in my comment. Sorry. Let's make, ooh, always fun. Okay. This is HCM in diagram. Okay. So in my so over here in this diagram, I am saying this variable is going to take up this amount of space. Now, notice I very specifically drew the box so that it's 4 boxes wide. The reason for that is an integer. This integer is 4 bytes. So one int is 4 bytes. Now you go, okay, what's a byte, right? What's a byte? Well, a byte, 1 byte is 8 bits. Okay, what's a bit? Well, a single bit is something that is our smallest unit of information storage, 1 bit. And a bit is really just 0 or 1. So if when we're talking about like what can a bit hold, a single bit, oh, sorry, I just realized that. Oh no, this is okay. A single bit holds either a 0 or a 1. That's it. Okay, and you go, wow, that doesn't seem like it's very useful. It's only 0 or 1, holds one of 2 things. This is true, but you put them together. So if you have 1 bit, then there's one value you can have, which is 0. There's another value you can have, which is 1. Not very interesting. But if you add just one more bit to it, well, you can have either 0, 0, like 2 bits, you can make 0, 0, or you can make 0, 1. But you can also make 1, 0 or 1, 1. So with just 4 bits, you are now able to get, sorry, with just 2 bits, you can get 4 values out of 2 bits instead of just 2 values. I go, okay, that still doesn't seem like a lot. Well, what if I add just one more bit? How much more am I going to add? Is it just 3 times more? Well, it's actually more than that. If I add one more bit, I can get 0. I can get these numbers, but with a 0 in front. Or I can get those same numbers with a 1 in front. So 0, 0, 0, 1, 1, 0, 1, 1. Okay? So now with 3 bits, I am able to get 8 different values out of that. And if I had 4 bits, then I will be able to get double the amount because there will be this pattern of numbers with a 0 in front and then the same pattern with a 1 in front. So I basically double every time I add a bit. So even though a single bit doesn't store a lot of information, the more bits every time you add another bit, you double the amount of information that you can store. Okay. So if I have 1 bit, I can store 2 pieces of information, and 8 bits make up a single byte. Within a single byte, how many different values can I have? Now, there's a way to calculate this, and I'm going to bring up my handy dandy calculator here to help me. So this is my calculator, okay? If I take the number 2 and I raise it to the power of 8, then I get 256. So if I have 8 bits of value, a single byte, I can store 256 different numbers with those 8 bits. Now, but I don't have 1 byte, I have 4 bytes in an integer. So how many different numbers can I store in 4 bytes? Well, 4 bytes is 32 bits. So it's 2 to the power of 32. And that number, by the way, if you want to count the zeros, right, what you're going to get is 4,294,967,296. Okay, that's how many different numbers you can get for a out of an that you can store within an int. Okay, now because there could be negative numbers, what we really do is we use one of the bits to indicate positive or negative, and then we use the other 31 to indicate the value. And 0 is considered like on the positive side. So if we take 2 to the power of 31, this is, so the smallest number you can store in an int variable is negative of this number, and the biggest number is 1 less than this, because 0 has to be stored as well, so you have to be able to store the number 0, so it's 1 less than this number. Okay, now, but all you need to know is that as long as you're trying to store numbers less than 2 billion, you can use an int. Okay, that's all you need to know about that. So when I say int height in centimeters, what I'm doing is I'm putting these 4 bytes and I'm saying, okay, those 4 bytes, I'm going to be holding an I'm going to be holding an integer in it. Now, what about double? What does that do? Well, a double is a floating point number. So what it is going to do is, it is, first of all, it actually uses more space than an integer. So a double uses a total of 8 bytes. Okay, so this is a double. Now, instead of representing the numbers as a whole number, what it does is it's going to represent it as what we call a floating point number. Now, floating point just means numbers with decimals. That's the sort of like this is just the way that we express, numbers that have decimal places. That's all it is. Okay. So what are we doing with this value? I don't know why this is being weird. Oh, I think I know. Okay. Uh, sorry. So in any case, what we're doing with this floating point value here is we're simply saying this particular variable is going to have decimals. Okay, we're interpreting all the zeros and ones and saying, okay, uh, represent a floating point value, something with decimals with it. The way it does it, by the way, is actually pretty interesting. So some of you may recall from your school, like your high school times, something called scientific notation. Remember, it was something like 2.54 times 10 to the power 6 or something like that. That's a scientific notation. And that's usually for if you have like a really big number and you really don't care about most of the digits that are going to be 0 because they round to 0. You would express it like this, so you don't have to write out all the zeros. That's what they do. That's what they do for floating point numbers. So part of this double is going to be storing something called the mantissa. Now, what's the mantissa? Well, it's really simple. It's this part of the scientific notation. We call that the mantissa. And then over here, we don't have to store the number 10 because it's always 10. This part is the exponent. So what it will do with a double is they will use part of those bits. Some of those bits are going to be used to store the numeric representation for the exponent, and some of those bits are going to be used to store the mantissa. That's pretty much how they make use of that space to represent floating point. Okay, so that's that. Okay, now what does this? Sorry, this is not. This is height in inches. My bad. The name of this variable is height in inches. Okay, so that's this variable over here. Now that explains what these two things do. How do we what happens when we declare a variable? We go out and we grab some space. We grab enough space based on this data type, and we interpret the space using this data type as well. Okay. What does this scanf line then do? So this is the line where we're reading in the value. So first of all, why do I need to put this ampersand here? And what is this %d for? Well, the %d is pretty easy to explain. You're basically saying, hey, when the user enters something, you're going to interpret whatever they enter thinking that it's going to be an integer. That's what it is. This just says that whatever the user enters should be an integer. Okay. And if you enter the wrong thing, by the way, it's not going to put the number here, and it's not going to make any sense. Okay, so this format code is important because it tells the computer how to interpret whatever the user is entering. So we need this %d. Okay, that just means whatever I'm reading in is supposed to be an integer. What's the next little part? Height in centimeters. What are we going to do with that? Well, height in centimeters is the variable, right? But why can't I just put the variable there? What is this ampersand for? Well, this we're going to go a lot into this later in the course, but essentially this ampersand character right here is called the address of operator. Ampersand means address of operator. That's what it is. Okay. So for now, you can say every time I use scanf, I have to use ampersand. That's what you think about at the beginning. But what it is doing is this. So when we all, so C functions are passed by value, okay? In C++, there's another concept called pass by reference. That does not exist in the C language. So what that means is that we get a copy of the variable sent to scanf. And so instead of passing in like so what we're doing here is scanf needs to be able to put something into this variable, right? Like this like it needs to go into this memory location. And when the user, whatever they type in, scanf needs to say, okay, they typed in this. I'm going to convert this into bits and bytes, and I'm going to, put it into your variable. But it needs to know where to put it because memory is vast. So it needs to know where to put it. And what this ampersand is doing is it's going to say, hey, put it here, where the address of this variable is. Now, what's an address? Well, you see how there's a bunch of these little boxes all over memory? Those boxes, they all have an address to them. Just like if you have a bunch, like houses have address, that tells you where it is, right? Variables in memory have an address. It tells you where in memory those variables are. So what this is basically saying is when you read in the number from the user, put it into this address, put it at this address. So so think of it as like delivering a number to a specific location within memory. That's what this ampersand is doing here. Okay. Now later on, you're going to find that sometimes you don't need the ampersand depending on what you're doing, and the rules can get a little bit confusing about this. But if you just remember that what you're trying to do is scanf wants to know where to put something, and you need to provide the where. And in this case, what you're saying is put it at the address of height in centimeters. Take the number that the person is entering, put it where height in centimeters is. That's all this is saying. Okay. And finally, we do the calculations. Now, really important rule. This is in math, so left and right matters. Okay. This says take this thing and put it into this. Okay. So this mathematical expression, okay, is take. So it's basically saying height. It's taking this calculation, height in cm, dividing it by 2.54. And then you want to take that and you want to put this into height in inches. You're assigning the result into this, okay? So make sure that you don't do it backwards. If you do it backwards, it doesn't work. It won't compile. You get an error out of that, okay? And that's pretty much it. Okay, so hopefully this explains what this little program does. I'm going to put up both. The code as well as the video. That's it for now. Talk to you later. Bye bye.